Now let us talk about X center, or rather X centers. Okay. Now what is X center? Let us say I've got this triangle here. Okay. And I extend the two sides like this, and I take angular bisectors of these two exterior angles. Okay, these are angular bisectors. All right, then these two angular bisectors will meet at a certain point. Now the internal angular bisector of this angle here will also pass through this point. So this is known as one of the X centers. Okay, why one of the X centers? Because we will have three such X centers. If I extend these two sides, now again I can take angular bisectors of these two exterior angles, right? And if I take angular bisector of this angle here, then they will meet at this point, and this is another X center. Similarly, I have got one more X center here. All right, now this X center lies on the angular bisectors of these two angles, right? So this will be equidistant from this side and this side, also from this side and this side. Why? Because we already know that if I take an angular bisector of a certain angle, then every point lying on the angular bisector is equidistant from the sides of the angle. Okay, so by that logic I can say that this X center will be equidistant from this side and this side as well as this side. What I mean to say here is that I can draw a circle touching all the three sides of the triangle externally, okay, having this as my center. So this circle is known as X circle. Okay, obviously we will have three such X circles for this triangle, right? So the circle touching all the three sides of the triangle externally. All right, okay, so let us discuss about X center and X circle a little more. Let me draw a triangle once again. Okay, I'm drawing a smaller triangle, and then I'll extend these sides like this. Let me name these points A, B and C. So this side length here is called small b, this side length is small c, and this side length is small a. Okay, for a moment I am erasing this small a just to keep the diagram clean. Okay, now see, let me draw these angular bisectors and this interior angle bisector, and these meet here, and let me name this point as IA. This is one of the X centers. It is, as it is opposite this vertex A, I have named it like this. So here if I've got this one of the X centers here, I'll name it IB, and similarly IC. All right, so let me draw a circle meeting the three sides externally. Okay, so if I join this point IA here to the tangent to this side, so this angle will be 90 degrees. This angle here is also 90 degrees. Okay, now I want you to look at these two triangles for a moment. One ACIA. I want you to look at this triangle, this one ACIA. Okay, if you look at this triangle, and if I consider this B as my base, then if I ask you what will be the height of this triangle, height of this triangle will be this segment here, right? If I call it RA, if I denote it by RA, which is nothing but the X radius, and let me join the center here also. So this angle will also be 90 degrees and this length will also be RA. Now see, what I'm trying to say here is, let us say if I've got a triangle like this, if I've got a triangle like this, okay, if I consider this as my base B, what will be the height if I extend it like this and drop a perpendicular here? So this will be the height. Okay, if this is triangle, by convention I should take it as B, right, because I'm considering it small b. So A, B, C, if this is my triangle, then this height can be exterior to the triangle, right? In the similar manner, if you look at this triangle ACIA, this RA is its height. Okay, why I am telling you this? Because I want to calculate the area of this triangle here, ACIA. What will be the area? Area of triangle ACIA. It will be equal to half into base B into height RA. Okay, and this RA is nothing but X radius. This is known as X radius. This is X circle. This circle is known as X circle, and this radius is known as X radius. So here, if I draw a circle with this center, then the radius I'll call, let us say, RB. Similarly, I'll have this circle here and I'll call the radius as RC. So I'll have 3 X circles, but whatever we prove here will be true for the rest of the circles also. So area of this triangle ACIA is half into small b into RA. Similarly, what can you say about this area ABIA? Area of triangle ABIA, it is equal to half into base C into height. What is the height of this triangle? This triangle, this is again RA. So this is RA, right? So I have calculated these two areas. Now I want you to calculate a third area, this one, area of this triangle, area of triangle BCIA. It is equal to half into base BC, which is small a, right, into height, which is nothing but again small RA. What was the height of this triangle? This is the height, which is again the X radius, right? So it is half into A into RA. Now why have I calculated these areas of these three triangles? Because if I add these two areas, this one and this one, and subtract this area from these two, then I'll obtain the area of triangle ABC, which I am interested in, right? If I add these two areas, give me a moment, let me erase it so that the diagram becomes a little cleaner. See, if I add these two areas, this area and this complete area, and subtract this area, then I'll obtain the area of this triangle ABC. So what is the area of triangle ABC? Area of triangle ABC will be equal to this half into B into RA plus this, which is half into C into RA, minus this half into A into RA. Now I can take half into RA common, so I'll have inside B plus C minus A, right? So now B plus C minus A can also be written in a simplified manner. How? Because you already know that semi-perimeter is nothing but A plus B plus C by 2, right? So if you know about the semi-perimeter, then you can think about this expression also, because this expression is nothing but b plus c minus a. So you can think about it like this: b plus c plus a minus 2a, right? This expression here can be written like this. This is now nothing but twice of semi-perimeter. So this entire expression here is nothing but twice of semi-perimeter minus 2a. This is 2s minus 2a. Okay, now if you will take 2 as common, this can be cancelled with this 2. So this can be written in a simplified manner like this: half into Ra into 2s minus 2a. Now in the next step you can write it as Ra into s minus a. So this is the area of triangle ABC. Now area of triangle ABC can be calculated in terms of other x radii also. What I am saying is, if you consider RB, then you can write S minus B here. Or another way to write this area can be RC S minus C. So these are nothing but areas of this triangle ABC in terms of the x radius, okay, x radii, different x radii. All right, so from here you can say x radius RA is nothing but delta upon S minus A, where this is the area of the triangle concerned. I hope you have got idea about x radius and x center and x circle. Okay, all right, so I think this much should be enough about x centers for the time being. And let me also tell you about the coordinates of x centers, right? Again, I am not going to prove the coordinates of x center. These are just these can be easily proven, but by using external division of a line segment. But for now you just need to memorize these. So if I want to find the coordinates of this x center here, these will be nothing but, you know, the coordinates of in center, right? What were the coordinates of in center? These were ax1 plus bx2 plus cx3 divided by a plus b plus c, right? ax1 plus bx2 plus cx3 divided by a plus b plus c. This was the x coordinate of the in center. Now I've got three x centers. This x center will have coordinates. I just need to change the sign of a here. So I'll just have to write minus a and minus a here. So this will be the x coordinate of this x center. Similarly, if I want to write the coordinates of this x center, I'll change the sign here only. So the x coordinate, if I want to write of this x center, it will be ax1 minus bx2 plus cx3 divided by a minus b plus c. Similarly, I can write the y coordinate, and in the similar manner I can write the coordinates of this x center. So let me tell you the coordinates of this x center: ax1 plus bx2 minus cx3 divided by a plus b minus c. And what will be the y coordinate? ay1 plus by2 minus cy3 divided by a plus b minus c. So this x center has got these coordinates, right? I hope these will be very easy for you to memorize.